Hi everyone! This video looks at a strong acid titrated with a strong base and will focus on the pH calculation after the equivalence point. This is a situation where our titrant volume is more than 0 milliliters, which means we have to set up a millimole table. The E row of our millimole table tells us where we are on the titration curve and guides us as to how to calculate the pH from that information. In this generic millimole table, we are only looking at the E row. Here, we see that the H plus goes to 0, which means it has completely reacted. The hydroxide is greater than 0, which means there is excess or more than what was necessary to fully react with the acid. This situation puts the reaction progress in region 4 of the titration curve, which is after the equivalence point. This is sometimes called excess titrant. To calculate pH after the equivalence point, we first have to calculate the hydroxide molarity. We get this by taking the millimoles of hydroxide from the E row and dividing by the total volume. We get the total volume by adding together the milliliters of acid and base given in the problem. Once we have the hydroxide molarity, we will calculate the pOH by taking the negative log of the OH. Then we'll get pH by recognizing that pH plus pOH equals 14. Rearranging this equation gives us pH equals 14 minus pOH. The 14 is not exact. It comes from K water, which is a measured value. We use K water to 2 sig figs, which gives us 2 decimal places in 14.00. In our example, we see that we do have more than 0 mils of titrant, which tells us we need a millimole table. So we'll start by calculating the millimoles. For our acid, we have 10.00 milliliters of solution times the molarity of the acid, which is 0.04000 moles of H plus per liter of solution. Liters of solution will cancel. And taking a look at sig figs, we have 4 sig figs in our volume, 4 sig figs in our molarity. So our millimoles will also be at 4 sig figs. Doing the math, 10.00 times 0.04000 gives us 0.4000 millimoles of H plus. For hydroxide, our volume is 13.01 milliliters of solution times the molarity of the hydroxide, which is 0.03125 moles of OH minus per liter of solution, and our liters of solution will cancel. Looking at the sig figs, we have 4 sig figs in this volume, 4 sig figs in our molarity, so these millimoles will also be rounded to 4 sig figs. Doing the calculation, we have 13.01 times 0.03125 rounded to 4 sig figs gives us 0.4066 millimoles of hydroxide. Setting up our millimole table, our reaction is H plus plus OH minus, forming water. Our rows are ICE, and our units are millimoles. Plugging in our values, for H plus we have 0.4000, and for hydroxide we have 0.4066. And we'll just put a line through the water. Doing the subtraction, we will subtract 0.4000 from each reactant, because that's the smaller number. And that will give us 0 for hydrogen ion and 0.0066 for hydroxide ion. The next step is to recognize where we are on the titration curve. Because the H plus is at 0 and we still have some hydroxide in solution, this is the situation that is after the equivalence point. To calculate the pH, the first thing we need to do is calculate our hydroxide molarity, and we'll get that from the millimoles, 0.0066, that we had in the E row, and divide that by our total volume. So our total volume is 10.00 plus 13.01 milliliters. Taking a look at sig figs, notice we only have 2 sig figs in our numerator, and we'll have 4 sig figs after we do the addition in the denominator. So our final molarity for hydroxide will be rounded to 2 sig figs. So doing the math, 0.0066 divided by 23.01 rounded to 2 sig figs gives us 2.9 times 10 to the negative 4 molar. Our next step is to calculate the pOH, and that is the negative log of 2.9 times 10 to the negative 4. We have 2 sig figs in that value, which means we'll end up with 2 decimal places in our pOH. So taking the negative log of 2.9 times 10 to the negative 4 gives us 3.54 out to 2 decimal places. And then our final step is to calculate the pH, and we get that from 14.00 minus 3.54. Both of those values are 2 decimal places, and it's a subtraction, so our pH will also be rounded to 2 decimal places. So 14.00 minus 3.54 gives us a pH of 10.46.